Bismillahirrahmanirrahim. Exercise 2.2, question number 1 in part 3, 4 and 5. This is our target now. This is question number 1, part 3. We have to find the derivative by first principle of 3t plus 2 to power minus 2. Let's start. Let's take y equals to 3t plus 2 raised to power minus 2. Step number 1, replace t by t plus del t, y by y plus del y. Step number 2, we will open up this bracket and meanwhile we will bring this y over here with a negative sign. Here it is. Next step, we will put y equals to 3t plus 2 to power minus 2 here and we will arrange these. We will bring this 2 over here and we will rearrange these three terms like this. Now we are going to apply binomial. We are going to take this 3t plus 2 common because the power is negative. So we have to use the formula of 1 plus x to power n. For that we have to take this 3t plus 2 common. So when we take this common, it will take its power minus 2 with itself, and inside the bracket we will have 1 plus 3 del t by 3t plus 2, and the power is minus 2. Now we will use the binomial expansion or the binomial theorem for negative exponents, which is 1 plus x to power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus so on. It is applied only when x mod is very small, less than 1. You can see this is in place of x. So as del t approaches to 0 means this whole number is also a very small value. So we can apply the expansion of 1 plus x to power n here. Let's write the expansion. What do we see? This term is as it is and we are using expansion here. 1, then plus the next term is plus nx. The value of n is minus 2 and the value of x is this. So you can see this is in place of n, this is in place of x. 1 minus 2 into 3 del t by 3t plus t plus next term n into n minus 1 by 2 factorial x square. So we write all these terms minus 2 minus 3 by 2 factorial 3 del t by 3t plus 2 whole square plus so on, and there are infinite terms in here. There is no last term. And then comes this term. Now what we are going to do? We are going to extend this bracket up till here. That is, we are going to take 3t plus 2 to power minus 2 common from this term also. As a result, we will get this bracket over here and we will get a minus 1 in place of it. We are going to take this term common. 3t plus 2 to power minus 2 common and this thing. You can see it is here. 3t plus 2 to power minus 2 is not written here. It is inside now and we have taken it common and we have got a minus 1 here. Next step, this 1 and minus 1 got cancelled. Next step, we see that there is del t in every term, 3 del t in every term. So we take this 3 del t common. So you can see there is no 3 del t here and you can see there is 3 del t to power 1 here. But first we have square here and now this is 3 del t only. Square is only on the lower term. Here it is. Next step, we have to divide both sides by del t. Here it is. Now this del t got cancelled and then we go for the next step, which is to apply limit on both sides. So we apply limit when del t tends to 0 on left side, limit when del t tends to 0 on right side. And what is the result? This is called dy by dt. And here we will put a 0 here and every term, every next term has got del t in it. So all the next terms become 0. So this is it, dy by dt. This term is as it is, this 3 as it is, this minus 2 as it is, this term as it is, and then all the next terms are 0. So simplify this thing, you will get minus 6 and 3t plus 2 to power minus 2, and there is a minus from here and we get this thing as the answer. Let's get to the next question. 1 by next question, 1 by ax plus b to power 5. What is written here? Follow the solution of part 5. In fact, these two questions, part 4 and part 5, are almost similar. So we are going to solve, I'm going to solve part 5 for you, and you may follow that solution and you may take help from that to solve part 5. Let's get to part 5. Let's get to part 5. This is it. 1 by az minus b to power 7. Solution, let's name it as y, and then I'm adjusting y. I have taken it as to power minus 7, az minus b to power minus 7. Now I'm going to follow all the steps which I have done in question number in the solution of part 3. Let's see what are those steps. Step number 1, y plus del y and a into z plus del z. Now I will open it and rearrange it, and I will bring this y over here. You can see all these are done. Open the bracket, y is here. Now put the value of y equals to this and rearrange it. Here it is. Now take this az minus b common, and you will have az minus b to power minus 7 here outside. And here you will have az minus b under this term. Here it is. Now as del z is a very small number, so this whole number is also very small. We can apply the expansion of 1 plus x to power n, where n is equal to minus 7 and x equals to this. So apply the expansion, this term as it is, and expansion 1 plus minus 7 into this term, a del z by az minus b, then minus 7 into minus 7 minus 1, that is minus 8 by 2 factorial. What is this term? A del z by az minus b, and we get a square now, plus so on. Up to, we have infinite terms, and all the terms have got del z in them. And then we close the bracket, and then minus az minus b to power minus 7. Now the same steps which we used in part 3, that is, we are going to write this bracket over here, and we will write a minus 1 in place of it, because az minus b to power minus 7 is common. Here it is. This minus 1 and 1 got cancelled, and then we see when these two terms, this 1 and minus 1, is cancelled, then we see that every term has got a del z. So we take that a del z common. Minus 1 and 1 are cancelled, and next step, take this a del z common, and you get inside the bracket minus 7 and then 1 over this, and then a del z over this square, and so on. And now we go to the next step, which is divide both sides by del z. So divide del y by del z and 1 by del z here. This del z got cancelled, and we apply the limit when del z tends to 0. This del z has been cancelled, and now we apply the limit. Here it is, limit when del z tends to 0, limit when del z tends to 0. So what will happen here? This will be called del y by dy by dz, and here no del z, no del z, no del z. So all these terms will remain the same, and here is a del z. So this becomes 0, this whole term will become 0, plus all the next terms have got del z in them. So all those terms will become 0. Here, this is the result. And now simplify it. What you will see, I will see minus 7a, and I will bring this over here, and 1 power here and plus 7 power. So I get this result, and that completes the solution.